In this video, we will be reviewing Chapter 9, which is all about properties of transformations. So starting out in 9.1, we start out with some vocabulary. So we have an image, that's our new picture, and a pre-image. So the pre-image is our original picture. So anytime that we have a rule, for example, x plus 3, y minus 1, this is a rule. So I take point A, which is negative 1, 2, and then I use the rule by adding 3 to x. So this will now be A prime, and that's going to be negative 1 plus 3, comma, 2 minus 1, or A prime is 2, comma, 1. Alright, so the prime notation is very important so that we can denote a difference between our image and pre-image. This would be the pre-image, and this would be our new image. Alright, and we should be able to graph. So in 9.1 is the very first time we see the word isometry. Alright, which means that maintains congruent lengths and angles. Alright, so it is a congruent figure. And we also begin discussing vectors, which have a direction and magnitude. Alright, so there are two components. There's a horizontal component and a vertical component. And this is very similar to the rule, so if I go back, I'm going to use this rule. However, I will transform it into a vector instead. So 3, comma, negative 1. So that means whatever point I have, it is moving 1, 2, 3, positive in the x direction, and then it moved negative 1 in the y direction. So that is what my vector would look like. It's not necessarily at specific coordinates, you're just counting the blocks that it's moving. And this is my initial point, and this is my terminal point. So if this was labeled KH, this would be vector KH, and it is important that you list them in that order with that symbol. Alright, moving on to 9.2. 9.2 discusses dimensions of matrices and all the properties of matrices. So, matrices. Alright, so we do need to know the dimensions. It's rows by columns. For example, this matrix right here, which is a rectangular arrangement of numbers, is a 2 by 3. 2 by 3. And we need to have the dimensions listed like that so that we know if we can add or subtract or multiply. So in order to add or subtract, dimensions must be equal. Alright, and in order to multiply, we need to have an m by n, and then on the right side an n by p. So those had to be the same, and then our new dimension would be an m by p. Hopefully you guys remember that process with the scooping and pouring. I do have another video that I've previously posted on adding and subtracting and multiplying matrices, so feel free to check that out. So that is 9.2. When we move on to all of the upcoming transformations, we can either use the rules like we have before, or we can use matrix multiplication. So 9.3 discusses reflections. And if you are looking for the rules that I am talking about, that is going to be on page 590, where we have over the x-axis. So that takes AB to A negative B. Alright, and so on and so forth. We have y-axis, we have over y equals x and over y equals the opposite of x. I asked you guys to go ahead and jog your memory and memorize those. So I do want to do an example of that. So example, I'll do over the line y equals x, and I am going to look up my transformation, and that takes AB to BA. I did tell you guys that I would give you the matrices, so from those you should be able to figure out what these rules are. So B now goes in my first spot, so this is B and this is A right here, and then A goes in my second spot. Alright, I don't have to multiply anything by negative. So if this was B, this would be B prime. And I need to make sure that everything is labeled with primes. Always. Make sure that everything has a name to it. And on page 592, you should be able to see the matrices for those x and y axis reflections. Matrix transformations. Will always be on the left. And I'll go ahead and do an example of that. So the x-axis reflection, this is x-axis reflection. This is the matrix, and I will give these to you. Alright, if I have, let's say, a triangle, A, B, and C, 0, 5, negative 2, 1, and 4, 3, we need to use our matrix multiplication in order to transform these. So I'm going to scoop and pour. So that means in this A prime spot, I have 0 times 1 plus 0 times 5. And then when I scoop and pour again, I have 1 times a negative 2 plus 0 times 1 in the B prime. And then C prime, wrong area. I scoop and pour again, so that's 1 times 4 plus 0 times 3. Alright, and then I can do that again for the bottom. Scoop and pour, 0 times 0 plus negative 1 times 5. Scoop and pour one more time. 0 times negative 2 plus negative 1 times 1. And then lastly, 0 times 4 plus 3 times negative 1. Alright, those pieces go to 0, so A prime is going to end up being 0, negative 5. B prime, that goes to 0, that goes to 0, it's going to be negative 2, negative 1. And C prime, those go to 0, is going to be 4, negative 3. Alright, so just double checking here, this was a 2 by 2 and this was a 2 by 3, so that means I could multiply it and my result's going to be a 2 by 3. Alright, which is very true. This is a 2 by 3. I get 3 points out, and that would, if I were to graph all of it, it would look like a reflection over the x-axis. Moving on to 9.4. We deal with rotations. Alright, so in a very similar manner, we have all of the rules which are on page 599, the coordinate rules, and then on page 600 are the matrices that I will give you. And it does say that rotations and reflections are both isometries, so it maintains the integrity of the lengths, side lengths, and measures, and the angle measures as well. So I'm not necessarily going to work out a full example like I did for reflections because it's very similar as far as the rules go. I'll just do one quickly for 270 degrees, rotating 1 point K. So here is K, and it is at 2 comma -7. And my rule for 270 degrees says I take AB to B negative A. So that means K prime is going to be, this is B, this is A. So I want to have B in the first spot, -7, and then the opposite of A, so that would be -2. And if you were to graph these for the record, a 270 degree rotation, if I have 2 -7, it's going to be all the way down here versus -7, -2, that's going to be over here. And if I draw some lines connecting them to the origin, you would see that this should be about 90 degrees, which would make sense since I moved it 270 degrees. And that's just one way, is quickly graphing and drawing a quick sketch. Just to confirm. Alright, and then in 9.5, we have what is called a composition. So that just means you have multiple transformations. Okay, so I'm going to have my original point A, and that is going to be 1, 3. Alright, and then I'm going to say x-axis reflection. X-axis reflection, that's going to give me A prime. And so then when I go over the x-axis, that makes it 1, -3. And then I'm going to go ahead and say, apply this vector, this component rule. So I'll say 5, -3. Alright, vector has the little pointy braces there. Alright, so that would become 6, comma, -6. And that's your final answer. Alright, so a composition means that we have multiple transformations that are happening, and I'm going to be using multiple primes. Alright, in 9.5, in 9.6, we talk about symmetry. So we have line symmetry and rotational symmetry. Alright, arguably, this is the easiest yet hardest concept because you really have to be a visual learner in order to see. So on a typical just regular triangle here, how many lines of reflection do I have? Well, I can draw one line down this way, and that way it would fold onto itself. I could draw another line this way and a third line this way. So 3 lines of reflection, or 3 lines of symmetry, either way. And we not only need to be able to identify how many lines of symmetry it has, but if it has rotational symmetry as well. So using the same triangle example, typically we are rotating around the center of the figure or another point or an origin. Alright, so I want to see if I spin this triangle all the way around, I want this point right here in the bottom right to land on this point. So I want to see how many degrees that would be. Alright, and so what I end up doing is I'm actually kind of splitting a circle. Think of this circle into 3. So I know there's 360 degrees divided by 3 angles that are created. That's 120 degrees. So I know that it has rotational symmetry for 120 degrees, 240 degrees, adding another 120, and then all the way to 360, which that's kind of, you don't need to put that. Everything has 360 degrees of rotational symmetry. Alright, and then lastly in 9.7 we have dilations. Dilations are the only non-isometries. They're not isometric, which means since they are either reducing or enlarging, they do not maintain the same measures, the same lengths. One of the formulas that I gave you is K equals, that's our scale factor, CP prime over CP, or if the problem's set up differently, I would go ahead and say PQ prime, P prime Q prime over PQ. Alright, so the prime should be on top. That's the really big note there. Prime in numerator. Now, what makes it a reduction is if K is between 0 and 1, and if K is greater than 1, that means it is an enlargement. And you would see that if you were to transform the points that you were given and actually graph them, you would see, you know, a triangle or a line growing or shrinking. So one way that we're going to be using those scale factors is with our lovely matrices. And all we have to do on problems like this is we go ahead and distribute to every single component, every single element. So this becomes 12, this becomes 0, 4, 8, -4, and -12. Alright, and it would be the same thing if I were distributing 1/4. I would just multiply every single element by 1/4 instead. And I can give answers as fractions or decimals. Either works. Alright, if you guys have any follow-up questions, please feel free to send me an email or see me in the morning before school. Good luck studying.